Orthogonal transformations. Fields are everywhere. I will list two examples and then I will generalize the idea of the field. In evolution, my first example, extinction events are characteristic in the past 500 million years. Blue indicates the extinction events here, but we can know that no two extinction events represent the same ecosystem, the same biological complexity. In red line, I indicated that the complexity during evolution is increasing, and this is just a symbolic representation because complexity is very difficult to measure. When we look at what happens between two extinction events, we can draw a thermodynamic cycle. And here from A, B, C, and D represents changes in characteristics. Between A and B, the compression of the ecospace happens because of overpopulation, the degradation of the environment, and the competition for resources becomes fierce, and this makes the ecosystem vulnerable for environmental influences. And eventually, disaster causes massive extinction. An extinction event clears out the ecosystem. It leaves survivors isolated in distant pockets of the environment. It eliminates predator-prey cycles, symbiotic relationships, and competitions that exist in a normal ecosystem. So it leaves the living fauna and flora devastated. The ecosystem empties out, and between C and D we can see that the individuals are isolated into distant corners of the environment, and the recovery can start. The plenty of nutrients allows evolution and recovery. And the ecosystem fills up, predator-prey cycles form, symbiotic relationships, competitions form, and there is a balance. But eventually the cycle will repeat. And if we look the cycle between AB and the CD side of this cycle are opposite of each other. The CD is low entropy, low population number, and plenty of nutrients. And this order increasing phase allows complexity to increase the genome can form organization toward formation of a complex organ. In contrast, the AB phase will be chaotic, high entropy, and the competition is fierce because the resources are dwindling, and the population number is high, and this becomes the typical Darwinian evolution, the survival of the fittest. But overall, both low entropy and high entropy phases are necessary, because in the CD, the formation of the innovations of the genome can be weeded out of the failed experimentations of the earlier phase. My other example is cognition, where the brain forms a so-called resting state in the absence of stimulus. But no two resting states are the same. Stimulus will cause a change in synaptic organization, and this is what intellectual evolution is like. A thermodynamic cycle can represent this change, where the stimulus will come in, causes high frequency activation, and the recovery of the resting state in the CD phase requires a synaptic reorganization, so that will allow different response in the future. And the common theme between the two examples were the existence of some kind of field where the energy can accumulate of the thermodynamic cycles, energy gain can accumulate. So this field soaks up the energy and makes it irreversible, while the thermodynamic cycle was reversible. It could run in any direction. And in the first case, the field was a genome, which represents complexity. And in the second case, in cognition, it is the synaptic map that gains this energy and complexity. If we draw the field just with a smooth line, then we can see that the thermodynamic cycle is connected to the field, and there can be exothermic and endothermic changes which allow difference in the field evolution. The field, the thermodynamic cycle has a characteristic direction, and on the left here I indicated exothermic cycle the loss of energy is goes to the field, and in the right, a gain of energy happens, which comes from the field, fueled by the field. So the field can contract or relax depending on the relationship. In the standard model, particles are represented by a compact dimension, and this agrees with the idea in quantum mechanics and string theory. If the compact dimensions are insulated from the gravity field, then and space and time, then they can form this thermodynamic cycle without interference. And I represented the gravity field by a square, just to indicate that it fills space. So instead of 3 dimensions, it's represented in 2 dimensions. This particle can form entanglement, and this is a fundamental nature of interaction and all change. And entanglement would create a different outcome for the sister particles, and here I just indicated it with a different size of circle for the particles. And entanglement is of course reversible. Theoretically it can happen at infinite distance. How could 2 sister particles remain connected at infinite distance? If this is insulated from gravity and space, then the wave function can stretch out like toffee candy and remain the same wave function. This is identical to the idea of wormholes, which are of course very small size, but the particle is tiny also. So this is in agreement with that idea. We talked about entanglement, which is reversible, but decoherence, which is interaction, is an irreversible transformation. That means that decoherence must conserve energy. So if the wave function changes, the field curvature must change as well. And here I represented an increasing energy wave function, increasing frequency wave function, and the field curvature will form positive curvature. And the opposite happens in the upspin condition. And the frequencies are reduced, particle frequencies are reduced, and the field curvature relaxes as well. What happens in a larger scale? Here I showed 2 sister particles that change the curvature of the field. And we can see that even though the changes are tiny over large scale, the field form notable, significant curvature, and at a certain threshold, the field curvature will direct the particles' spin direction. Namely, at positive curvature, it will force downspin on the particles. And at negative curvature, it will allow and invite upspin. As a result, the field will develop poles. At the positively curving field will force a drop. It will create such pressure that the dimensionality will drop, and the black holes will be two-dimensional, will form two-dimensional horizons. At the opposite case, white holes will form, which will gain dimensionality, and white holes will be four-dimensional. The characteristics of these poles are interesting, and the black holes will be two-dimensional, information saturated, hot, very high temperature, time will be infinite there, and entropy will be high. In the white holes, the dimensionality will be four-dimensional, the information will be zero, time will be zero because time starts here, they are just born, the dimensionality. Temperature will be cold, and entropy will be also high due to the expansion of space. And on the left, space is zero and time is infinite. And on the right, in white holes, which we recognize must be cosmic voids because of the cold temperature, time is zero and space is infinite. Because from our perspective, three-dimensional perspective, four dimensions are really infinite space. And this orthogonal relationship between the poles force a constant interaction on the three-dimensional regions. And this leads to constant change and biological evolution that we experience in our, on Earth. The characteristics of these two different entities are listed. The compact dimensions are non-local. They are described by quantum mechanics and entanglement, which is reversible. And the gravity field has local behavior, and the interaction is irreversible, which evolves the field, and at every point of space it has a definite energy level. Near the black holes, the field strength is enormous, and likewise the mass is enormous, which results in immense inertia. And it is the opposite near the cosmic voids, where inertia is non-existent. It also explains dark energy because the cosmic voids would expand the universe, and they push against the immense field strength of the black holes and create the impression of dark matter. This picture is surprisingly similar to the idea proposed by LANIAKEA in 1997, the anti-de Sitter conformal field theory correspondence, which shows that there is a hyperbolic geometry connected to a two-dimensional horizon. The idea is also supported by Tully and his colleagues, who measured our cosmic neighborhood. The immense cosmic void is pushing our Milky Way galaxy toward a sphere that is mostly made up of black holes. This is the picture of our LANIAKEA supercluster home, and we are part of this immense supercluster. In conclusion, we can see that the cosmos is made up of an endothermic and an exothermic cycle, and this is not surprising because in nature exothermic processes make endothermic ones possible. However, what is surprising is that in the dimensional anisotropy of the universe, it is the endothermic cycle that makes the exothermic ones possible, because the expansion of space is that what triggers interaction and all change. In conclusion, we can say that time is information and space is energy.